Welcome to the recording of CSC109, Inheritance and Polymorphism. So in previous classes, we talked a lot about object-oriented programming, and we're going to continue that conversation today talking about inheritance and polymorphism. So we're really going to be immersed in ideas for a while because object-oriented programming can take a while to understand. And its goal is to make programming easier by giving you fewer things to think about. And we do that in three ways. First, we map to real things in the real world. And we did this in CSC103 when we talked about creating classes. We also in that class talked about hiding details. So we talked about, private versus public and things like that. And now in this class, we're going to look at taking advantage of our natural tendency to think about one thing as a type of another thing. For example, like a dog is a type of animal. So we're going to be focusing on that today. And then we'll finish up by talking about another object-oriented programming concept called polymorphism to make our inheritance more flexible and as such more useful. So we're going to start with inheritance, and we're going to look at how inheritance can help us with object-oriented programming. And our task for this first objective is to understand how and when we should use inheritance. So it's natural for us to think of one thing as a type of another thing. Usually it will be either a more specific thing or a more general thing. So for example, a monkey is a kind of animal. And a computer or tablet or phone is a type of computer. So as you can see, monkey is specific, whereas animal is general, and tablet, phone, laptop is specific, and computer is general. We tend to think like this. So this creates a hierarchy that helps us to describe how these things relate. And the farther down the hierarchy tree we go, the more specialized we get. And the further up the tree we go, the more general things get. So for example, at the top we have animal, which is very general. And as we travel down, you can see we have mammal and bird, which is more specific. And then even going down, we have horse and dog, which is a type of mammal, and duck and parrot, which is a type of bird. So we travel down, we get more specific. Now we can create classes that derive from other classes by using a C# feature called inheritance. And when a class inherits from another, it retains all of the features like properties, methods, fields of the other class, which we often refer to as the base class. The new class or derived class has all the abilities of the base, but can also be extended, meaning that we can add new functionality, including new properties and new methods. So take a look at the example on the screen here. The book class defines common properties of a book, and we could inherit from book and create a non-fiction book class that helps keep all of those properties, but adds additional things that are only relevant to non-fiction books. So for example, here we have a property or field called is biography, which is specific to a non-fiction book. But because non-fiction book derives from book, non-fiction book will also have a title, authors, current page, total pages, and a way to read it. Now the class at the top of this hierarchy is called the base class, or sometimes also referred to as the superclass. And the class that inherits from the base class is called the derived or subclass. And since the derived class inherits everything in the base class, we only have to write common code in one place, which is the base class. And then we can reuse that code in our derived classes. We can carry this even further by having our derived class be the base class for an even more specialized class. And the class at the bottom of the tree inherits everything from the classes directly above it. So dog gets everything from mammal as well as everything from animal. Now, when you're deciding to use inheritance, you can think of it as a is-a relationship. We need to be careful not to use inheritance for unrelated classes, because this can cause problems when we try to use them interchangeably, as we'll see in a little bit. So, for example, here, if we use the is-a test, if we say an animal is a plant, or a chair is an animal, you can see those do not work. It breaks the is-a relationship. So you should not model these using inheritance. So in C#, we define these relationships with a colon when we define the class. So here we say mammal derives from or extends from animal, and dog derives from mammal. So like I said, you would read the colon as derives from. So mammal derives from animal, and dog derives from mammal. Now here we have a class animal, and it has a speak method. And dog inherits from animal, so that means that dog inherits that speak method as well. Dog also defines its own property called breed. So if I make a new instance of dog called Fido, I can use the breed property. I can also use the speak method because the speak method came from the animal. And this works because a dog is an animal, therefore it can speak. Now, if we look at this example here, notice how this is a little bit different. Once again, we have the same animal class. We have a dog that derives from animal. But notice what we're doing here. We're saying animal equals new dog. So that means the variable is of type animal, but it's actually pointing to a dog. And does that work? Can we do that? Well, yes, it turns out that we can because a dog is an animal. So we can store a reference to a dog in a variable of type animal. The only problem is this. This does not work because animal.breed, breed is a property from dog. And since we're using a variable of type animal, we can't access it. We're actually limited a little bit. Now, if we really want to access it, we can. And I'll show you an example in the next slide. But before I do that, you may be wondering, well, why would I ever do this? Why would I ever create a variable of type animal and store a dog inside of it? And the answer is you would typically use stuff like this for methods or maybe lists or collections. You know, imagine you had dogs, pigs, cats, all types of animals, and you wanted to create a collection, like a list, to store all of these animals in one collection. Well, if you had a base class, you could create a collection of the base class and then store all of those classes inside of that list. So if I had a list of animals, I could store dogs, cats, pigs, and everything I wanted inside of it. So like I said before, if you have a situation like that where you have animal equals new dog, we know that behind the scenes, dog is, or animal is really a dog, right? Animal is really pointing to a dog. We just can't see the dog things because we're looking at it through the eyes of an animal. But we know it's a dog, so if we want to get the dog traits out of it, we can convert it back into a dog variable. And we could do that with using many different techniques. One technique is using the as keyword. So you can see here I'm saying dog Fido equals animal, which is really a dog, but I'm saying take that animal and treat it as if it was a dog. If that conversion is successful, Fido will be something that is not null. And if the conversion is unsuccessful, then it will be null. So after you use the as keyword, it's common to check for null. And in this case, if it's not null, then we access the breed property and everything works just fine. Now remember that when we create an instance of dog, the constructor is called to initialize the instance to a known and proper state. But when we use inheritance, we also have to initialize the base or parent class. So since dog inherits from animal, the animal parts of the dog also have to be constructed. So this is actually done automatically. This is not code that we have to add ourselves. So you can see here in the derived class, it will actually inject a call to the base class constructor. Now, this will only happen if the base class constructor is a default constructor. If it's not, like in this case, now we have a parameter, the system cannot inject a call to the base class constructor because we no longer know what to pass into the parameter. So we actually have to manually call the base class constructor. And the way that we do that is we have to use this syntax. After our constructor, we say :base, and then in parentheses, we'll call the base class constructor. So in this case, we're passing in the name of the animal through this call. And remember, this is necessary because a dog is an animal. So everything an animal has, a dog has to have, which means we need to call the base class constructor so that the animal is in a prepared state, which means that the dog will be as well. So what I want to do now is I want to jump into a flash quiz. But remember, since this is a video recording, after I read the question, I'll pause for a second to give you a chance to pause your video and think about the question, and then after that, I'll come back and actually answer the question. So question number 1, is the following statement correct? Mammal Fido equals new dog. And the answer here is C. Yes, but you only get the mammal properties and methods. If you look at the diagram on the right-hand side, you can see horse and dog derive from mammals. So I can definitely assign a reference of a dog to a mammal, but I can only see the mammal things. Number 2, inheritance allows you to treat a derived class like the base class. Is that true or false? And the answer here is true. Yes, inheritance does allow you to treat a derived class like a base class, basically meaning that we can store a derived class in a variable of the base class. Number 3, we use inheritance to express blank relationships. And that would be A, to express is of relationships. Alright, so let's now jump into our first exercise and look at how we can create a class that derives from another. So here we are in the starter solution of exercise number 1. And our goal for this exercise is to basically take the add operation that we currently have. As you can see here, we have a class called add operation that does basic addition. We're going to take this and try to move the common functionality here into a base class so that we can easily add multiplication and other operations by just deriving from the base operation class. And as you can see back in program.cs, our job is to perform a multiply operation. So to start us off, we're going to create a new class. And I'm going to create this and call this operation. This is designed to be the base class. Okay, so inside of operation, we want basically the common functionality between all operations. And if you think about it, that's going to be the actual storing of the numbers. Because if you look at add operation, first number and second number, all our operations will have that. But the actual calculate method, that's specific to the operation. So basically all of this code we can rip out and put into our shared definition. So let's do that. Let's go to our operation class and let's create the properties. So we'll say public int first number, and then we'll say public int second. Okay, then we'll create our constructor, and in our constructor, this will take in the first and second number. And then we'll simply just assign those to our properties. So now we have our base class. So going back to add operation, we want this to derive from operation. So now operation is the base class. And notice that it's complaining already. It's complaining because operation has a base class constructor that we're not calling. You can also see that we're getting warnings. You can see a warning here is saying that add operation first number hides the inherited member operation first number, which means operation already has one, which means we don't need these in here because we already have one from base class operation. And we don't need these. all we have to do is call the base class constructor. So when the add operation's created, we're going to call the base class, passing in number 1 and number 2, which will then jump into here. Number 1, number 2 will then be assigned to these properties. We're also just going to make the operation class public. Okay, so now we have the add operation class done. And now we're going to create the multiply operation. So I'm going to go ahead and right click on my project again, go to add class, and I'm going to create a multiply operation. Now in my multiply operation, once again, we're going to derive from operation because that's where our shared functionality is. And then inside a multiply operation, we need a constructor again. So we'll say public multiply operation, int n1, int n2. And then we'll simply just call the base class constructor, passing those in so that the base class is created. And then we need just the specific functionality for multiply operation. So we'll create that calculate method. So it's public string. We can actually just go back to add operation and copy this. And we can paste that into here. And we're going to change this to multiplication instead. So we'll change that to multiplication or an X, doesn't matter. And then we'll change this to multiplication here. And now with our multiplication operation done, if we head back over here, now we need to perform the multiply operation. We can simply say multiply operation, multiply, equals new multiply operation. We'll say 10 and 20. And then we'll console.writeLine multiply.calculate. And if I run this now, you'll see that in the output, it has 10 plus 20 is 30, and 10 times 20 is 200. And now we could also easily implement division, subtraction if we wanted to. Everything would work fine. So we looked at making a class to hold common functionality, which is the base class. And then we looked at inheriting from that class in a derived class to basically get and inherit all of that base class functionality. Now let's look at making our inheritance more flexible and more useful. So first, we're going to define the object-oriented programming concept of polymorphism, and then we'll put it into practice by using virtual and abstract methods. So what exactly is polymorphism? And polymorphism means many-shaped, and it really has two major aspects. And we've seen one of these already. So the first one is derived classes can be treated as objects of a base class at runtime. So what that means is that's that list example. A list of animals can store dogs, cats, pigs. Anything that derives from animal can be stored inside of an animal variable. But the second aspect is derived classes can replace or extend the behavior of the base class. So this means that a derived class can actually sometimes change the functionality of the base class in respect to the derived class. And you'll see exactly what I mean by that in just a moment. So here's the first aspect, as you can see. So on the left-hand side, you can see we have a class called fruit, and then we have apple, banana, and grape that all derive from fruit. So that means that I can do things like this. I can create a variable of type fruit that holds a reference of type variable or type apple because apple is a fruit. And I can also make a collection of fruits, and it can store apples, bananas, and grapes because they derive from fruit. Now, what I cannot do is something like this. I can't say apple bad fruits equals new fruit because a fruit is not an apple. Fruit does not derive from apple, so I can't store a reference of fruit inside of apple. Same being if I create an array of apples, I can only store apples inside of them. I cannot put bananas and grapes. Now, when you create base classes, we can define methods as being virtual. And this allows derived classes to replace or extend this method inside the derived class. And so this is done by placing the virtual keyword before the return type in the method signature. And the base class provides a default implementation, and then each derived class can optionally replace the virtual method with their own unique implementation. And in this example, each derived animal can speak differently, for example. So here you can see in the base class animal, I have a virtual speak method. And then inside of my dog class, I can override that speak method. And I'm saying something else. So in this case, if I were to call dog speak, it would say woof instead of grr like the default animal did. So for example, here you can see I have 3 variables. I have Fido, Spot, and Cuddles, and they are of type animal, but they are references of dog, pig, and bear. And you can see when I call speak on them, they're saying they're appropriate sounds because we overrided the virtual method of speak in each of these. And this is a lot cooler when you look at an example like this. As you can see here, we have a list of animals that has references to dogs and pigs. And if I loop through this list and I call speak on every single animal in the list, it will say the correct sounds because, once again, we overrided the speak method. And the cool thing with this is, even though we have a reference of type of animal, we are still getting the derived class's implementation of that virtual method. But we said that I can choose to override a method or not. If I don't override the method, then we go right back to the base class implementation of the method. So as you can see here, we have a bear, and we're using the bear speak method. But since we did not override the speak method inside the bear class, it defaults to that default grr sound. Now here, the dog class inherits from the animal, but overrides eat. And instead of duplicating code, you can use the base keyword to call the base class implementation. This is useful when you want to extend the base class implementation. So as you can see here, if, for example, base.eat was above console.writeLine, that would allow me to first call the base class, do whatever the base class eat method does, and then come back to this and then do whatever I want to do in this class. So you can either completely replace the base class implementation by not calling the base class like we're doing here, or if you want to call the base class, then we can extend the functionality of it. Alright, let's do another flash quiz. Number 1. If dog derives from mammal, can a dog object be in an array of mammals? And the answer here is yes, it definitely can. Number 2, if dog derives from mammal, can a mammal be in an array of dogs? And the answer here is no, mammal is not deriving from dog, so we can't store mammals in an array of dogs. Number 3, polymorphism allows derived classes to override or replace the behavior of the base class. And that would be A, true. Cool. Alright, so sometimes we want a virtual method to be forced to be overwritten. Because, for example, we have a class here called animal, and we have a method called speak. Well, what should the actual default implementation be? What do animals speak? And the hard part of that is because animal is not a concrete type. It's not specific enough. There's no such thing as an animal, right? So I can't say an animal makes this sound because it depends which animal you're talking about. So in reality, there should be no code for the speak method inside the animal class. So in that case, if I mark the method as abstract, I do not provide a body. Notice how there's no body, just a semicolon at the end of it. And this now means that anyone who implements this class and derives from this class has to override the speak method. If they don't override it, they'll actually get an error. Now, since the method has to be overwritten, I don't put any implementation into the body because it has to be overridden. And since I don't have any code in that method, I need to make sure that it never gets called on the base class. And I can do this by marking the base class as abstract itself, which means that this class has to be inherited from. You can't create an instance of this class anymore, because imagine if you had an abstract method with no code and then you created an instance of this class itself. What would happen if you called that method? There's no code in it. It wouldn't be able to do anything. So by having an abstract method, we would also make our class abstract so that it can only ever be used as a base class. You could never instantiate it itself. So as you can see, now in our derived class, we are forced to override the speak method. We don't have an option. And as you can see, like I said before, since animal is now an abstract class, we can no longer call new directly on the animal. We can only use animal as a base class or a base class variable like we see here, but we can't call new on. We can't create a pure instance of animal if it's marked as abstract. Alright, so what I want to do now is to finish up the class, I want to jump back into an exercise and talk about how we can override virtual methods. So here we are back in the completed solution from exercise number 1, because we're going to continue on from this. And what I want to do is I want to start with program.cs. I want to modify this, and we're going to run into problems, but hopefully polymorphism will fix it. What I want to do is I want to be able to take all of my operations, put them into a list, and then loop through them and calculate all at once so that I could have a very large list and I don't have to manually keep on calling calculate. So without changing anything, let's try to go ahead and rewrite this into that. So I'm going to make a list of operation, and this will be called my operations. Oops. Okay. Now in my operations, I'm going to add these operations into it. So I'm going to basically take this operation and add that into my list. So I'm going to say operations.add. We have an operation there. And I want to take my multiplication operation, and I want to add that as well. And as you can imagine, I could potentially have many operations. That's the whole point of this. So let's add a couple more. Let's fix all these errors that I caused. And let's change these numbers a little bit. So let's delete all this code down here. All right, so I would like this idea, right? We have a list of operations that can have tons of operations. These operations could be created dynamically, like we don't know where it's coming from. And then I would like to say, okay, let's go through all the operations. So for each operation in my operations list, let's go ahead and calculate. So let's say operation.calc. Oh, wait a second. As you can see, I'm having a problem. I can't call calculate because operation is the base class and it doesn't define a calculate method. As you can see, in add operation and multiply operation we have calculate, but in our base class it doesn't, which it should. We should be able to share that common functionality because all the derived classes seem to have it, so why not put it into the base class? So let's do that. Now if you think about it, the base class operation will probably not ever need to call calculate on itself because operation itself doesn't actually mean anything. It needs to be in a specific operation like add or multiply. So I'm going to make it abstract because I don't want to provide a definition. So I'm going to say public abstract string calculate. Okay, and I'm also going to mark the class as abstract as well. So now with this, remember, if you have an abstract method, now our derived classes are forced to implement it, are forced to override it. So as you can see, we already have it. We just need to add override to these. And let's add that to here as well. And now, as you can see, if we jump back to program.cs, notice how in my IntelliSense, calculate is now there because we defined it in the base class, but it's being implemented by all the derived classes. And we know for a fact that it's implemented because it's marked as abstract, which means every derived class has to implement it. So we know for a fact that this is now going to work. So if I run this, as you can see, all of my operations are now displaying. So in this last section, we talked about virtual methods and abstract methods. And remember, virtual methods are methods that can be overwritten by the derived class, but they're optional, whereas an abstract method is forced to be overwritten by the derived class. So I want to say thank you for hanging out and taking the time to watch this video. If you have any questions, you can always send me an email at jediet@microsoft.com. Once again, thanks, and I'll see you around in future XAMU classes.